welcome to lesson 4.6. We'll be working with equations that contain decimals. When solving equations that contain decimals, what we're going to do is we're going to follow all the rules that we have regarding decimals and follow all the rules that we have about solving equations. For example, if I had a problem that didn't contain any decimals, x minus 3 equals 8, I would add 3 to both sides of the equation, so I'd have x equals 11. Now I have decimals, so the same rules apply. In case of x minus 3.5 equals 8.7, I'm going to add 3.5 to both sides. So add 3.5, add 3.5, 3.5's go away, and I am left with 8.7 plus 3.5, that gives us x equals 12.2. Line up the decimals. 7 plus 5 is 12, carry the 1. 8 plus 1 plus 3 is 12. So solving equations containing decimals, we just need to remember all of our rules about decimals. 4 times y, so 4y equals negative 3.32. Again, if this was all whole numbers, I would just divide by 4. So let's go ahead and divide each side by 4. Now off to the side, I know my solution is going to be negative because I only have one negative. And I go off to the side and I do my division. 4 goes into 3 0 times. 4 goes into 33 8 times. Remember, the only rule I have to remember is where I place my decimal, straight up. 8 times 4 is 32. 33 minus 32 is 1. Bring down the 2. 4 goes into 12 3 times. 3 times 4 is 12. 12 minus 12 is 0. So my solution is a negative 0.83. For another example, 1/2 x minus 2.59 equals 3.81. I'm going to start off, I'm not going to convert everybody to decimal yet. We'll see if we can get through this problem without having to convert to decimals for the 1/2 anyway. I'm going to add 2.59 to both sides. So I have 1/2 x equals 6.40. But I'm going to multiply by the reciprocal, and the reciprocal of 1/2 is 2. So I multiply both sides by 2, and 6.4 times 2 is going to be, well, 2 times 0 is 0, 2 times 4 is 8, 2 times 6 is 12, and I have 2 decimal places, so my solution is going to be 12.80, or 12.8 is fine. Let's work through a few more examples here. 7a plus 0.61 equals negative 5a minus 0.89. I want all of my variables on one side and all of my numbers, my constants, on the other. And for this instance, I'm going to move my variables, I'm going to get them all to the left-hand side. And it doesn't matter, you could have moved them to the right-hand side. Your solution would be the same. I'm going to add 5a, so now I have 12a plus 0.61 equals negative 0.89. I want to get rid of the 0.61 using my addition property of equality. I subtract or add a negative 0.61 to both sides. The 0.61 disappears on the left, and now on the right I have negative 1.50. Divide by 12, divide by 12. And if you do that math, it's going to be a negative 0.125. That's it. So we're following all the rules of having decimals, following all the rules of solving an equation. Another example, I've actually done it a couple of different ways. 1.18x plus 0.24 equals 0.84x minus 0.78. Now the first way is I kept all the decimals and I just worked with the numbers that I'm given. So subtract 0.24, subtract 0.24, that goes away, leaving me with 1.18x equals 0.84x minus 1.02. I need all of my variables on one side of the equation, so I'm going to subtract 0.84 from the right, subtract 0.84 on the left, leaving me with 0.34x equals negative 1.02. Divide by 0.34, divide by 0.34. My solution is x equals negative 3. Now you might remember a second way of solving this equation is to get rid of all the decimals, to eliminate all the decimals. Well, right now there are 2 decimal places to the right of the decimal, and each one of my numbers, in fact, 1.18, 0.24, 0.84, and 0.78. If I multiply each side by 100, meaning each term on both sides by 100, I'll get rid of the decimals. Pardon me. 1.18 times 100 is 118. 0.24 times 100 is 24. 0.84 times 100 is 84. And 0.78 times 100 is 78. Now I don't have any decimals to deal with. I'm going to subtract 24, and go through the same process, and you'll see my answer is exactly the same. Now let's take an actual problem, and this one is a car rental problem. A car rental company charges $11 per day and 16 cents per mile for their cars. If a car were rented for 1 day and the charge was $25.40, how many miles was the car driven? Well, think about this. Start with the total rental charge of $25.40. Well, we have a daily charge of $11. Why? Because we rented the car for 1 day, and that was a flat fee to rent the car for 1 day is $11. So out of the rental charge, $11 of it is the daily charge. Let's subtract, leaving us with $14.40, which is the mileage charge. But the mileage charge is per mile fee, is 16 cents. That's a division problem. So divide 16 cents into $14.40. That will give us 90 miles. So you drove 90 miles. Another way of looking at this is algebraically. So, I know my daily charge is $11. What I don't know is the number of miles I drove, and that's going to be multiplied by the 16 cents. And that total charge is 25.40. Subtract 11. Subtract 11. 0.016x equals 14.40. Divide by 0.16. Divide by 0.16. X, the number of miles, is 90. So either you can think of it kind of logically, lay it out, or think about it algebraically. My total charge is going to be my daily charge plus the mileage charge. Well, I know what that is. That's $25.40. Then I have to subtract the daily charge and figure out the mileage that way. So I think in the real world we don't necessarily set everything up algebraically. We may set it up kind of logically, but it's exactly what we're doing in algebra. I subtracted 11. Well, I would subtract 11 in the algebraic format. I divided by 0.16. Well, I divide by 0.16 in the algebraic. It just so happens that I have x equals 90 versus 90 is my solution up on top. Right? So think about this not necessarily do you put it in an algebraic form in the real world, but you are using all of your skill set that you're learning now to solve a problem like this. Let's try a coin problem. Diane has $1.60 in dimes and nickels. If she has 7 more dimes than nickels, how many of each coin does she have? Well, it's a lot of information. She has a total amount of money of $1.60. and it's all in dimes and nickels. She has 7 more dimes than nickels. We don't know how many nickels she has. That's our X, that's our unknown. We do know she has 7 more dimes than nickels. Well, if nickels is X, then dimes must be X plus 7. Now the value of dimes would be the number of dimes I have times the actual value of 1 dime. Well, 1 dime is 0.10 cents, right? It's 10 cents, which is 0.10. So 0.10 times the number of dimes that I actually have, which is X plus 7. I don't know why I was so hesitant on writing that, but yes, working with my mouse here. And then nickels, well, that's 5 cents, 0.05 times the number of nickels I have will give me my total amount I have in nickels. Well, if I add the amount I have in dimes plus the amount I have in nickels, that will be my total amount that I have in my pocket, or at least in Diane's pocket, $1.60. Now, solving the problem, there's a couple ways we can go about it. We can, again, keep all my decimals, or I can multiply everybody by 100 and get rid of the decimals. So if I multiply everybody by 100, multiply him by 100, multiply nickel value by 100, and multiply the total amount by 100, I will eliminate decimals. So I have now 10 times X plus 7 plus 5 times X, oh, that was a really bad X, sorry about that, equals 160. Distribute the 10 to both the X and the 7, so I have 10X plus 70. Oh my goodness, my writing. I'll be so glad when I get my pen back. Plus 5X equals 160. Alright, so I can subtract 70 from both sides. That will give me 90. And I add my like terms. 10 times 10 plus X plus 5X is going to give me 15X. Divide each side by 15. Divide 15X by 15. Divide 90 by 15. X equals, well, let's see, 15 and 15 is 30. Plus 15 is 45. Plus 15 is 60. Plus 15 is 75. That's 6. 6 answers one of the questions. How many of each coin does she have? She has 6 nickels, right? Because that's where our X was. Dimes, she has 7 more dimes than she has nickels. So that's going to be 6 plus 7. So X plus 7 is the number of dimes. That's 6 plus 7 is 13 dimes. Here we go, 13 dimes and 6 nickels. Let's try one more problem. Cell phone service provider charges $49.99 a month for unlimited texting and 450 anytime voice minutes. And the cost for each minute over our 450 minutes is 45 cents for each minute. If the customer's bill is $104.89, how many minutes is he over the limit? Now I'm going to set this up algebraically. I know my total amount of my bill is going to be my flat charge, my $49.99, plus the charge per minute times the minute I used. So if I set this up algebraically, it's going to be 49.99 plus 0.45x, because I don't know how many minutes I used, equals 104.89. Subtract $49.99, subtract $49.99, I get 0.45x equals 5490. Divide by 0.45, divide by 0.45. Therefore, you can plug this into a calculator if need be. X equals 122. Therefore, I chatted 122 minutes over my allowance. But how many minutes in total did he talk for that month? Well, that would be the 450 plus the 122. So that would be 572 minutes in total. So be very careful about, at least when you're doing the problems, if you're doing this for your homework, be careful about what the question actually asks. If it asks for the minutes over his limit, the answer is 122. If it's total minutes, then you have to add the original 450 minutes in there. That's it for this video. And the more I look at my writing up there, I apologize greatly. I will do better when I get my pen back. So until next time, be seeing you.